Alright, everyone. Welcome to week 3 of Finite Help Show. I'm Andrew Roosh from Roosh Tutoring, and today we're going to be talking about combinations, permutations, committees, and couples. Some big words. So first off, let's talk about combinations. Well, what is a combination? It's basically a mathematical way of calculating the number of possible combinations of a smaller set from a larger set. So here's the equation that you have n factorial over n minus r in parentheses factorial over r factorial. Big words. Here's the example. Let's say we have a set of 6. How many sets of 3 can we choose from that? Let's say you have 6 friends. How many different ways can you choose 3 of them to go get ice cream with you? Well, we can set that up right here. N is our bigger number, right? So we put it up here, n factorial. Also 6 factorial, and we do 6 minus 3 factorial times 3 factorial. That factorial just means that you multiply the number by every successive number. So you get 6 times 5 times 4 times 3 times 2 times 1 divided by 3 times 2 times 1 over 3 times 2 times 1. These two cancel. The 3 times 2 equals 6. That cancels, and you're left with 20. So there are 20 different sets of 3 that you can choose from 6. Easy enough. Then we have permutations. Now, that's a number of ways a subset can be ordered from a larger set. So in the earlier case of combinations, all we cared about was how many sets. In the case of permutations, it's not only the number of sets, but also the order of those sets, right? So in this case, we have our 6 2's 3. The only difference is we don't have the extra number we're dividing this by. So the permutation is always equal to or bigger than a combination of something. So here, we have, if you have, let's say you're choosing like 3 people for parts in the play out of a group of 6, right? Well, if myself and my friend Joe and my friend Sam are in the play, and if we're playing The Lion King, then me playing as Mufasa would be different than me playing as Scar. So in that case, there's obviously a lot more ways you could order people and include that. So you have 6 factorial over 3 factorial, and then you get 120. Or if you thought of this as slots, you could just say, okay, well, there are 3 slots. There's 6 people to choose from. In the first slot, there are 6 choices. In the next slot, there's 5 choices. In the next slot, there's 4 choices. 6 times 5 is 30. 30 times 4 is 120. Easy enough. Well, let's move on to some word problems here. So let's, first example is you have a chairperson of the IUDM social committee must choose a subcommittee of 4 people from the whole committee of 8. So now how many ways can this be done? Well, what's our larger set? Well, first off, does order matter in this case? We're talking about a subcommittee, right? So did we talk about offices, or we just are choosing a group of people to be on a committee? Well, it would seem that order would not matter, so we want to use combinations here. So we have combinations, and our larger set is 8, right? We have 8 people, so we say, okay, combinations of 8, choose 4. Which then equals 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by, we have 8 minus 4 factorial over 4 factorial, right? Well, 4 factorial, this cancels out, and this becomes 4 factorial itself, so 4 times 3 times 2 times 1. So what we're left with here is, the other trick is to start canceling things that go together, right? So 4 times 2 is 8, so this can take out from 8, and then 6 divided by 3 is 2. So we get 2 here. So we have 7 times 5, that's 35 times 2 is 70. So there are 70 different ways, different subcommittees you can choose from the whole committee of 8 if you're choosing 4 for your subcommittee. Now, this case is a little different, right? Here we have our friend Lisa. And Lisa's been invited to a date party by Brad. And, Lisa's really into Brad. She thinks Brad's really swell and cool. So, she's all about going on a date with Brad. Now, Brad, unfortunately, he has friends that are sort of lame. And so Brad's figured to help out his friends and have Lisa get some girls from her floor to go to the date party with them. So Lisa's been tasked to pair up 5 girls with Brad's 5 friends. Now let's assume that Lisa has 10 girls that she can choose from to go to the date party with there on her floor. How many ways can this be done? Well, obviously here order matters, right? Because maybe Megan thinks that Chris is really swell, but finds Joe rather annoying, right? So order would matter in this case. So this would mean that we use a permutation. So again, we have a permutation of the 10 girls that we're choosing from, right? So we have 10, and we choose 5 of them, right, for a permutation. And of course, as the equation goes, we have 10 factorial divided by 10 minus 5 factorial, right? So then that gives us 10 times 9 times 8 times 7 times 6 times 5 factorial over 10 minus 5 is 5. So 5 factorial here. These cancels out. And you can do the math here. I'm going to use a calculator because I'm lazy. So 10 times 9 times 8 times 7 times 6. Well, that equals a very large number. That equals 30,240. So that's the number of ways that our friend Lisa can pair up her friends on her floor with Brad's kind of lame friends. So anyway, that is it for this week's help show. Again, my name is Andrew Roosh. I'm with Roosh Tutoring. If you have any tutoring questions, finite or calc, don't hesitate. Reach out. My number is 765-319-8657. Or you can find me at Facebook, facebook.com/IUtutoring. Thank you very much, and good luck this week.